On July 23rd, 2024, the ground at Yellowstone National Park made a wild promise, and for the tourists standing on a flimsy boardwalk in Biscuit Basin, it delivered. The explosion just happened. There was no tremor, no warning, no sound until a superheated column of steam, mud, and solid rock shot up between 400 and 600 feet into the Wyoming sky. Debris rained down, shattering any sense of safety. Some rocks were the size of grapefruits, others weighed hundreds of pounds. The boardwalk, where people had been moments before, was splintered, broken, gone, and yet, unbelievably, no one was hurt that morning. Not a scratch. It was a miracle measured in feet and seconds. But what the initial news reports didn't tell you was this. It wasn't a volcanic eruption. It wasn't some freak accident. This was the park's ancient, violent plumbing system just doing its thing. It was a hydrothermal explosion, which the United States Geological Survey basically says isn't just common, it's completely bound to happen. This wasn't the first time it occurred, and it certainly won't be the last. So the real question isn't if the ground under America's most famous park will blow again, but where it'll happen next, and if anyone will be standing there when it does. To really get what went down at Biscuit Basin, you have to toss out everything you think you know about Yellowstone. Forget the pretty postcards, the Buffalo traffic jams, Old Faithful going off on cue. Instead, picture the whole park as one giant, breathing geological machine. This machine runs on a huge, shallow pool of magma that boils the groundwater that seeps down from the surface. There's this maze of cracks and fissures forming a plumbing system, way more complicated than anything we could ever build. And this plumbing is always changing, and it's constantly trying to clog itself up. The same minerals that make the hot springs those amazing turquoise, orange, and yellow colors are also the system's biggest headache. Silica, which gets pulled from the volcanic rock by the superheated water, starts to harden as the water cools closer to the surface. It builds up, tiny layer by tiny layer, forming this hard, concrete-like seal called sinter. It clogs the vents, narrows the channels, turning a free-flowing hot spring into something like a capped pressure cooker with a geothermal furnace roaring underneath. The pressure builds. The temperature rockets past boiling, but the water stays liquid, trapped by all the rock and water above it. This is superheated water, and it holds a terrifying amount of energy. It just needs a little nudge, a slight drop in pressure, a tiny crack in that center cap, and boom, the water instantly turns into steam, expanding to over 1,500 times its original size in less than a second. What you get isn't an eruption, it's an explosion. Now, this isn't a new thing, it's just how geyser basins work. Geologists have watched it happen for decades. Like on September 5th, 1989, a small, quiet hot spring in the Norris Geyser Basin called Porkchop Geyser did exactly this. For years, it was just a gently bubbling pool, a minor spot most tourists walked right past. But underground, its plumbing was slowly getting squeezed shut. That day, in front of 8 park visitors, it blew up. It chucked rocks over 200 feet, pelting the whole area with stony shrapnel. The once calm pool was gone, replaced by a furiously steaming, roaring hole. The geyser essentially unclogged itself in the most violent way possible. It completely changed its structure, like pressing a geological reset button with explosive force. Porkchop Geyser was a warning, a clear example of what any of these peaceful-looking pools were capable of. Then, almost 30 years later, another feature reminded everyone that the ground really does have its own timeline. On September 15th, 2018, something called Ear Spring in the Upper Geyser Basin erupted for the first time in over 60 years. Ear Spring, named because it looked a bit like a human ear, wasn't known for doing anything wild. It was a calm, blue pool, a nice spot for a photo, not a place you'd ever expect to blow. But it did. The blast sent water and steam dozens of feet into the air, and it coughed up something else entirely: decades of human history. When the steam cleared, park staff found the ground around Ear Spring covered in garbage that tourists had thrown in over the years, now literally thrown back at them. There were coins from the 1930s, old beer cans from brands that don't even exist anymore, a huge concrete block, and, perhaps most famously, a baby pacifier from the mid-20th century. The geyser wasn't just erupting, it was cleaning house. It felt like geological karma, a clear reminder that these pools aren't wishing wells or trash cans. They're the outlets of a powerful, unpredictable system that doesn't forget what we feed it. The eruption was a story, a joke, something that went viral. But it was also a very loud signal that even the most sleepy features can suddenly turn violent. The pressure is always building. The system is always looking for a way to let it out. And that brings us to 10:00 a.m. on July 23, 2024. Black Diamond Pool, like Porkchop and Ear Spring before it, was a quiet place. A deep, dark blue pool in the popular Biscuit Basin. Just a few miles from Old Faithful, cell phone footage from that morning is eerily normal. Tourists are just walking around on the boardwalk, snapping pictures, enjoying the view. The air is still. The pool is calm. There are no alarms, no swarms of earthquakes, no ground bulging, no sudden temperature changes that geologists could pick up. The USGS seismic network, one of the most advanced in the world, caught nothing. Absolutely nothing. The explosion was instant. One moment, a peaceful pool. The next, a geyser of dark mud and rock shooting into the sky. The sound, a low roar mixed with the sharp crack of rock breaking. You can almost feel it even from the videos. You see people turn and run. You see them ducking as chunks of debris, some small pebbles, some massive blocks rain down around them. The boardwalk, built to keep people safe from the boiling ground, was destroyed. A rock the size of a small car landed just feet from where tourists were filming. Their escape was pure luck. A few seconds difference, a few feet in another direction, and this story would have been a tragedy. Instead, it became a terrifying spectacle. Right afterward, the internet did what it does. Speculation spread even faster than the geyser itself. Was this it? Was the Yellowstone supervolcano finally waking up? The answer, delivered with solid authority from the Yellowstone Volcano Observatory, was a firm no. Dr. Michael Poland, the scientist in charge of the YIVO, became the voice of scientific reason amid an online panic. In public statements, and in the USGS Yellowstone Caldera Chronicles, he carefully explained the facts. This was a hydrothermal event, not a volcanic one. It was caused by water, not magma. This distinction is a big deal. A volcanic eruption is when molten rock comes up from deep inside the earth. That's the event the world fears, the huge caldera-forming disaster that would mess with the global climate. But the magma chamber under Yellowstone is mostly solid, only about 16 to 20% liquid, and it shows no signs of building pressure for that kind of eruption. The volcanic alert level for Yellowstone stayed at normal/green. It never changed. This explosion was shallow. It was a steam-driven blast coming from the top few hundred feet of the Earth. Dangerous? Definitely. A sign of the end of the world? Not even close. It was, as the USGS said, the result of water suddenly turning into steam in the shallow hydrothermal system. It was a plumbing problem. Just a plumbing problem that happens to involve temperatures hot enough to melt lead and pressures strong enough to turn solid rock into powder. The science was clear, but what everyone saw was incredible. So, researchers went straight to the site. Dr. Lauren Harrison, a volcanic hazards researcher from Colorado State University, arrived with her team the very next day. They started the tough job of mapping the blast zone. They walked through the now closed basin, measuring the size of rocks that had been thrown out, checking how far they landed from the crater, figuring out the immense energy it took to launch them there. They were like forensic geologists, putting together a crime scene where the planet itself was the culprit. Their work confirmed how brutally powerful the event was. The explosion had dug a new crater over 30 feet wide and sent debris flying more than 300 feet away. The sheer force was mind-blowing, and yet it was tiny compared to what's happened there before. The blast at Biscuit Basin was scary, but it was also small. To really grasp what these events can do, you need to go to the northern shore of Yellowstone Lake. You'll find Mary Bay there. It doesn't look like much at first, just a gentle curve in the huge lake shoreline, but that bay is a scar. It's what's left of the biggest known hydrothermal explosion crater on Earth. About 13,800 years ago, This spot was the site of an explosion so massive it's hard to even imagine. The blast carved out a crater between 1.5 and 1.7 miles across, a hole in the ground so wide you could fit the whole country of Monaco inside it. The energy released would have been like a major nuclear bomb going off. Trees for miles around would have been flattened instantly. The sound would have been deafening for 50 miles away. Anything living nearby would have just turned to vapor. Today, you can stand on the shore of Mary Bay and have no idea you're standing on the edge of an ancient disaster. The signs are hard to spot. The shape of the bay, what the dirt is made of. But the geology doesn't lie. This is what the system can do when everything lines up perfectly. And Mary Bay isn't unique. Using sonar, scientists have found that the bottom of Yellowstone Lake is covered with dozens of other massive hydrothermal explosion craters. Elliott's Crater, another giant hidden underwater, is still actively spewing hot mineral-rich fluids into the deep, cold water. The park's biggest and most violent scars are hidden, a secret history of explosions far more powerful than anything we've seen recently. The 2024 event wasn't weird. It was a small-scale echo of a much bigger, more brutal past. It was a reminder of the power just lurking beneath the surface. The July 2024 explosion was a wake-up call for the agencies managing the park. It proved that these things could happen in popular, busy areas without any warning at all. The old ways of predicting them, like looking for earthquake swarms or ground changes, were useless for these shallow, instant blasts. A new plan was needed. The problem wasn't stopping the explosions. That was impossible. The problem was seeing them happen in real time, understanding what they were doing, and keeping people safe from a danger that could pop up anywhere at any moment. So the USGS did something really bold. They decided to outfit the basin with sensors for sound and sight. In the months after the explosion, scientists and technical staff installed a whole new set of monitoring equipment around the still-closed Biscuit Basin. They put up high-resolution webcams aimed at the most active thermal features. They set up infrasound sensors, basically, low-frequency microphones that can pick up explosion sound waves that are too low for humans to hear. They also upgraded the seismic network. They were basically setting a scientific trap for the area, waiting for the ground to act up again. They knew another event was coming. The only question was when. They didn't have to wait long. The answer came at 5:09 am on June 13, 2026, less than 2 years after the first viral blast. Another hydrothermal explosion ripped through Biscuit Basin. This time, it was about 100 feet north of where the Black Diamond Pool event happened. It was in the dark, before dawn, with no tourists around for miles. But this time, the USGS was watching. The infrasound sensors picked up the acoustic signature of the blast. The new seismic monitors recorded the subtle shaking. And crucially, one of the recently installed research cameras actually caught the event on video. The footage is grainy, stark, and totally captivating. You see a sudden flash of light on the thermal camera, a burst of intense heat as the ground tears itself open. A plume of steam and debris shoots into the dark sky. The engineering had worked. The trap was sprung. For the first time, scientists had a full, multi-instrument recording of a significant hydrothermal explosion from the very moment it began. In the days that followed, geologists carefully went into the area to check out the damage. What they found was amazing. The June 2026 explosion hadn't just made a simple crater. It had ripped a 61-foot long crack in the earth. The fissure was filled with almost boiling water, measured at 194 degrees Fahrenheit, churning and steaming in the open air. This wasn't just a hole, it was like a wound, a tear in the park's geological skin. Just days after their first look, the ground moved again. A part of the newly opened vent collapsed inward, forming a perfectly round crater 21 feet wide. Almost immediately, this new feature started acting like a geyser, shooting boiling water up to 30 feet in the air. A new landform, born out of violence, had appeared on the map in just days. Analyzing the event gave them a really interesting insight. Dr. Poland, talking about the new data, pointed out something important. He said that Black Diamond doesn't seem to have been affected by this event in a major way. This was a huge clue. It meant the two explosions, even though they were only 100 feet apart, weren't connected by one big underground system. Instead, they were very shallow events that impact individual features. This made the problem way more complex. It wasn't one big pressure cooker to keep an eye on. It was hundreds of tiny, separate, disconnected pressure cookers, each with its own plumbing, its own clogs, its own breaking point, and its own undetectable timer. The danger wasn't in one central spot. It was spread out, scattered across every geyser basin in the park. As of July 2026, Biscuit Basin is still completely closed to visitors. The ground is too unstable, the dangers too unpredictable. The National Park Service just can't guarantee visitor safety in an area that's actively and violently changing itself. The closure feels like giving up. It's federal authorities admitting that some forces of nature you just can't manage, control, or build around. You can only get out of the way, and yet people still fundamentally misunderstand the Yellowstone threat. The scary idea of the supervolcano keeps hanging around in everyone's minds, fed by disaster movies and clickbait headlines. People worry about the big one, the eruption that's supposedly overdue. But the USGS constantly keeps debunking this myth. Volcanoes don't operate on a schedule. They erupt when the geological conditions are just right, not because a certain amount of time has passed. The real, current, and proven danger at Yellowstone isn't the overdue supervolcano. It's the regular, frequent, and totally unpredictable hydrothermal explosion. These events happen somewhere in the park, often in remote areas, once or twice every single year. The April 15th, 2024 explosion at Norris Geyser Basin was so small that only the sensitive acoustic sensors picked it up. No one even saw it. But the potential for a bigger event, like the one at Biscuit Basin, exists in every single one of the park's 10,000 thermal features. Every geyser, every hot spring, every mud pot, every fumarole is a possible blast site. They're beautiful. They're mesmerizing. But they're also, at their core, ticking bombs. The Park Service and the USGS are stuck in an impossible spot. Their job is to let people visit while keeping them safe, in a place where the ground itself is fundamentally unsafe. The new monitoring systems, the webcams and infrasound detectors, are an amazing scientific achievement. They let scientists see and study these events with incredible clarity. But they're for recording what happened, not preventing it. They offer understanding, not protection. They can record an explosion. They can't stop one from happening under a crowded boardwalk. The tourists on July 23, 2024, got lucky. They walked away with an unbelievable story and amazing videos. They were eyewitnesses to one of nature's most sudden and violent processes. But their luck came down to inches and seconds. They were standing on the edge of a geological event that happens in milliseconds. There was no time to react. There was only time to run. The questions that linger are unsettling. The ground at Biscuit Basin is still active. The new fissure is still boiling. The new crater is still erupting. And all across Yellowstone, hundreds of other hydrothermal systems are slowly, silently, invisibly continuing their cycle. Minerals are hardening. Center is building. Pressure is rising. These explosions aren't a flaw in the system. They are the system. They are the reset. The violent, necessary act of a landscape unchoking itself so it can breathe again. The cameras are watching. The scientists are listening. But they're just observers. The clock isn't ticking down to one massive volcanic eruption. It's ticking down on 1,000 different